Hello everyone, this is Billy. I've been using this type of piezoelectric sound units and adding my 3D designs ear channel to form a earbud that I can listen to crystal radio. And this is so far the most sensitive ones I got. But today I'm going to try to use this tiny sound unit, which is called the Balanced Armature moving iron sound unit, to create a pair of earbuds that I will test and try on the crystal radio. I'll show you the testing result, but before that we'll need to design this 3D printed box to host this tiny balanced armature sound unit. I designed two types. This is a more conventional one for the crystal earbud, and this is a more modern, stylish one that you used for the latest hi-fi type earbuds. So I got both designs. I'll be sharing the print files so you can print it out and create your own. Watch till the end of the video and I'll give you the result of the testing. Thank you. You're watching the Billy C DIY channel, where I talk about hydroponics, retro game machines, Arduino projects, crystal radios, and any other stuff to do with do-it-yourself projects. To support my work, please subscribe to my channel, click like, subscribe, and share with your friends. And leave me some comments or questions. I will answer them as soon as possible. Thanks for watching. This is a closer look of the Balanced Armature earbud that I created. And this is another one that is more stylish. I came across this Balanced Armature sound unit 22955 with a maximum output of 133 dBA and 80 ohm of impedance. The response curve seems more towards the bass, but I'm looking for one with a better output, so I tried this one. This is how Balanced Armature sound unit works. It's a tiny needle that push and a thin piece of aluminum, the diaphragm, to drive the sound, and it's really small. To hold this tiny sound unit, I designed a case for it using Fusion 360. You can see that there's a section view of it. There's the sound channel that passes the sound to the ear, and the square part there holds the sound unit. The opening on the right is for the 2-pin connectors that we can make this earbud detachable from the rest of the cable. This is the cover for the chassis. Let me show you how this is built from scratch. I've put the link to the print files in my YouTube description. You can get it, download, and print it out using a 3D printer. If you use Cura as the slicer software, it will take 27 minutes to print out one. I also followed another YouTuber, Koz, K-O-E-Z-H, who show us how to build this very stylish, more modern earbud. I adopted this and modified it a bit for my crystal radio. This is how it looks. I added the feature to secure the CI-22955 Balanced Armature sound unit. The print files only create the earbud for the left ear. To create the right ear, you just use the multiply command in Cura and then use the mirror command to swap the position to the left side. You can print it out using your 3D printer. This is how it looks after the printout. I created two versions, one with the 2-pin connector and another one with just a hole, so you can just pass your wire conventionally and then solder it directly. However, I recommend you not to solder your long cable for the headphone directly to this balanced armature sound unit, because the connection pins are very fragile. So you need to be gentle, so better to use some thinner wire to connect them together first before you go to the longer cable. That is, in case anything happens, someone pulled it hard, the thinner wire will be broken instead of the sound unit itself. This is the CI-22955 sound unit. The left side is the positive terminal, the right side is the negative terminal, and the middle one is the midpoint of the coil that drives the moving iron. So this is the tiny wire that you should be using to connect your sound unit to a terminal before it goes to the longer cable. Either you use the 2-pin connector or you use another terminal as the intermediate connection point. This is to avoid any physical damage to the sound unit itself if someone pulls the long headphone cable. This is the 2-pin connector that you can use to connect to this longer headphone cable. This is what is being used in the more modern type of hi-fi headphones. Let's solder some thin wire into this sound unit first. Starting with the positive terminal, that's the one on the left. Then the negative terminal, that's the one on the right. Now we can solder them to the 2-pin connector. Soldering, be careful not to put too much solder because they may get to the inside of the small pipe that will block the connector. So let's try if connector can be connected okay. Let's check out their connectivity and the resistance. You should hear a click and then look at the ohm meter. It's around 15 ohm. See how much inductance it has? It's around 3.55 millihenry. You need to buy this type of diameter 1 millimeter tiny silicon tube to connect to the sound units, so the sound from the tiny opening can be carried all the way to our ear. Just cut out 1 inch and use it to connect it to the sound unit. Then we'll pass the tube through this tiny hole to the other end of the earbud. We need to push it all the way in. Then we could secure the 2-pin connector to the little notch over there and cover the chassis with this lid. We'll use some soft glue, don't use the super hard glue. The soft glue here is to fill up the gap between the silicon tube and the hole of the chassis. This is to avoid leakage of sound. We'll leave it for a few minutes to dry out while we examine the rest of the chassis to check out if everything is good. So this is the 2-pin connector. I put a label called Crystal at the chassis. You got the file, you can design your own label. Let's make sure the hole is not blocked, then we can trim out the rest of the silicon tube. Lastly, let's plug in the earbud silicon tip. I find that having a proper earbud silicon tip is very important to the volume of sound. Not only that it makes you feel more comfortable, but it creates the right sound isolation and also can channel all the sound energy to your inner ear. I've been using different type of earbud silicon tips and I find only a few of them suit my ear. So different people have different size, small, medium and large, and also how soft is the silicon tip is also important. There's also a memory cotton type silicon tip this red one that I've tried to use. In the end, I find that even though it's 10 times more expensive, the quality or volume of sound is much worse than the green one, which is pure silicon tip. So that's why I changed it back to the green one, which is 10 times cheaper but give better results. I tested the earbud using the FM crystal radio with this Yagi antenna, 1 unit Yagi antenna that I hang on my window. So this is the very simple FM crystal radio using the MOSFET as the detector and 5 turns of 1mm copper wire and a copper air variable capacitor. First, I test my original piezoelectric sound unit, which gave me the best result so far. So this is it. So to do that, I need to change the output impedance of my step-down transformer KPB-02. So I use the 128 ohm output. Input is 1.5 kilo ohm, which suits the MOSFET 3DQ. Then I plug in my new earbud, the one using Balanced Armature driver. I tune the crystal radio to the loudest FM station I can listen to, which give around 3 microampere of DC current output. I found the result very close to that of the piezoelectric sound unit, even though it's still a tiny bit lower output than that, but it's still reasonably good for listening to FM crystal radio. I also created this other one, which is more comfortable to wear. So this is what I have been testing. I will continue to look at whether there are newer balanced armature sound units which can outperform my piezoelectric buzzer. But for the time being, my piezoelectric buzzer sound unit is by far still the most sensitive one. Here are all the other components that you can get from the China Taobao website. I don't know whether they are available outside in other part of the world, but just for your reference. That's the end of the video. Thanks a lot for watching. If you like my video, please click like, subscribe, share with your friends, and leave me some comments or questions. I will answer them as soon as possible. Bye now.